Introduction to pH. pH tells you how acidic or basic a solution is. Pure water, H2O, is neutral with a pH of 7. Solutions that have a pH less than 7 are acidic. Solutions whose pH is greater than 7 are basic. So the pH scale goes from 0 to 14, with 7 being neutral. Something with a pH of 0 is very acidic. Something with a pH of 14 is very basic. But what does pH correspond to on a chemical level? The answer is the hydrogen ion concentration. Right, so a pH of 0 means a hydrogen ion concentration of 1.0 molar. This bracket H plus means molarity of hydrogen ion. So as we move to increasing pH, our hydrogen ion concentration is going down. And that makes sense, right? Because acids are hydrogen ion donors or proton donors. By the time you get to something that's really strongly basic, the concentration of hydrogen ion is very low. So we can see that as the concentration of H plus increases, pH decreases. But what's the mathematical relationship? pH equals negative log of hydrogen ion concentration is the mathematical relationship. Log is short for base 10 logarithm, which is a mathematical function. The logarithm of x is the power that 10 must be raised to get x. So there's that statement in English. The logarithm of x is the power that 10 must be raised to obtain x. We could also say 10 to the log x equals x. That's just the translation between the English and the math. It's the same thing. Here's a graph of the logarithm function. Notice its value increases very slowly. Let's make a little table. So, let's try 3 columns. Number, 10 to the x, which means what the power of 10 is that corresponds to that number, and then the logarithm of that number. So, if we have the number 1, that's 10 to the 0th power, and the logarithm of that is 0. The number 10 is 10 to the 1st power. What's the logarithm? Haha, you guessed it, 1. 100 is 10 to the 2nd power, and the logarithm is 2. 1,000, 10 to the 3rd, and the logarithm is 3. What about numbers that are smaller than 1, like 0.1? Well, that's 10 to the negative 1 power, and the logarithm is negative 1. You get the picture? What about 0.001? That's 10 to the negative 3rd, and the logarithm is negative 3. So, here's a table. On the left, this table just tells you about the hydrogen ion concentration versus the pH. Starting at pH of 7, that is a hydrogen ion concentration of 10 to the negative 7th molar, and that's what you get in pure water. and that's a neutral pH. And as we're moving down this scale, what we're doing is we are increasing the concentration of H+, right? Because 10 to the negative 6 is more than 10 to the negative 7. 10 to the negative 5 is more than 10 to the negative 6, and so on and so forth, until we finally get to 1.0 molar. That's a really acidic solution. That's a 1.0 molar solution of a strong acid. Right? And then when we get up to a pH of 14, that's a really low H+ concentration, 10 to the negative 14th molar. That is a 1.0 molar solution of sodium hydroxide or potassium hydroxide. Really strong bases. Now let's look at the table on the right. The gastric juice, that sounds appetizing, right? That's the stuff in your stomach, which has hydrochloric acid. That has a pH of 1. And look, 0.1 molar HCl has a pH of 1. So, your gastric juice has 0.1 molar hydrochloric acid in it. Lemon juice, super sour, has a pH of 2.3. So, lemon juice contains citric acid, which is not as, it's a weak acid. But still, pH of 2.3 is still much more acidic than 7. Vinegar, 2.8, it's a weaker acid or in lower concentration than the citric acid. And then HC2H3O2, also known as CH3COOH, acetic acid, is the active ingredient in vinegar. So, if vinegar has a pH of 2.8, that means it's a solution of acetic acid whose concentration is greater than 0.1 molar. Orange juice and tomato juice are still very acidic. Black coffee is very acidic. PP, it's about 10 times more acidic than water, not super acidic. Milk, a little bit more acidic than pure water. Blood is a tiny bit basic. And then we get on to things like ammonia, which you might use, it's a component of Windex, use it for cleaning your windows, that has a pH of 11. And 1 molar sodium hydroxide has a pH of 14. That's like what you'd find in Drano. Don't drink it, it'll turn your stomach into soap and you'll die. Here's an exercise. So when we say more acidic here, or factor of acidity, we're talking about how many times higher is the hydrogen ion concentration at pH 3 than it is at pH 5. So, if pH equals the negative log of the H+ concentration, then 10 to the negative pH equals the H+ concentration. And remember, the square brackets mean molarity of. So, what you need to do is find the hydrogen ion concentration when the pH is 5, find it at the pH of 3 as well, and then compare the two. Now go ahead and pause your video while you work. So here's my solution. At pH of 3, the H+ concentration equals 10 to the negative third, or 0.001 molar. At pH of 5, the H+ concentration equals 10 to the negative 5, or 0.00001 molar. And so now I just make a quotient with those two numbers. 0.001 over 0.00001. And I punch that into my calculator. And I get 100. So in other words, a solution at pH 3 is 100 times more acidic than a solution at pH 5. Let's do another exercise. What is the pH of a 0.020 molar HCl solution? And the equation you'll need to use here is pH equals negative logarithm of the H plus concentration. Now, how do you know the H plus concentration? Well, the HCl is a strong acid, which means it is 100% ionized in solution. Right, so if our concentration of HCl started out at, let's see, we'll make a table. I for initial, C for change, and E for equilibrium value. The initial concentration of HCl was 0.020, 0 and 0 for H plus and Cl minus. And since this is a strong acid solution, at equilibrium, the concentration of HCl is going to be 0, and the concentration of H plus will be 0.020, and the concentration of Cl minus will be 0.020. In other words, it's 100% ionized. This is the value that you're going to plug into your pH equation. Pause and work it. So here's my solution. pH equals the negative log of 0.020. So I literally find the negative button on my calculator, and then I find the log button on my calculator. Make sure you're using log base 10 and not ln, which is base E, and then I punch in 0.02 and then enter. And I get 1.698. So I'm going to call it 1.70. Another thing, our concentration had 2 sig figs, and in pH only the numbers to the right of the decimal are significant.